Hello everybody and welcome to today's lesson on similar polygons in 2 dimensions and 3 dimensions. Today's objectives will be we will be able to use similar objects in 2 or 3 dimensions to compare ratios between side lengths, perimeters, areas and volumes. We will also be able to determine how changes in one or more dimensions of an object affect area and or volume of the object, and how changes in area or volume affect other dimensions. And we will be able to solve real-world problems about similar geometric objects. Okay, first of all, let's remember what we discussed in the last class about similar polygons. Similar polygons have the same shape but different sizes. That means that the angles of those polygons are congruent and the sides are proportional. That means that there is some type of relationship between corresponding sides of those objects. They can't just be randomly different. So the relationship between corresponding lengths in similar polygons is that the ratio of any 2 corresponding lengths is equal to the scale factor. And let's underline the word any. And when we talk about lengths, what are we talking about? What different types of things do we have that we call lengths? They could be the sides of a polygon. They could be altitudes, perimeters, and so on. And here goes our example. Given is that triangle CAB is similar to triangle DEB. First, we have to find the scale factor of triangle CAB to triangle DEB. In order to do that, we need to take 2 corresponding sides and compare them. Well, if we start here at the beginning, we get that side CA is corresponding to side DE. Now CA is this side over here, and CA is 6 plus 6, so 12 units long, and DE over here, 8 plus 8 is 16 units. So CA over DE is equal to 12 over 16, which we can of course simplify to get 3 over 4. We could also write it with a colon, 3 to 4, and this is our scale factor. Next, we're supposed to find the length of the altitude FB. Now, what is altitude? Altitude FB, we are talking about this segment here. Altitude is another word for height, and the height is the side which is perpendicular to the base of a triangle. And if we look at our triangle CAB and imagine that it was flipped 90 degrees to the left, then you could see that CA is the base and FB is perpendicular to it as indicated by the right angle, and that's the height or altitude. So, what is the length of FB? We can see that FB has to be corresponding to the length GB, which is the height or altitude of the other triangle. And We know now that the scale factor of any length in these two triangles is 3 over 4. So FB over GB is equal to 3 over 4. Fortunately, we know that GB is 20 units long, so FB over 20 is equal to 3 over 4. And now we can go ahead and cross multiply to solve this proportion. And we get 4 FB is equal to 60. Divide both sides by 4. And we get FB is equal to 15. And that is the altitude of triangle CAB. Next, we're supposed to find and compare the areas of each triangle. And luckily, we have been given the formula to find the area back here. The area is equal to 1/2 B times H. Now, what do B and H stand for? B stands for the base of a triangle, and H stands for the height, which we have already mentioned before. And again, the height is the length which is perpendicular to the base and goes from the base all the way up to the top of the triangle. Then the area of triangle ABC is equal to 1/2 times 12 times 15. 1/2 times 12 is 6, so 6 times 15 is going to be equal to 90. And the area of triangle DEB is equal to 1/2 times 16 times 20. 1/2 times 16 is 8. 8 times 20 is 160. But we're also supposed to compare the two areas. So let's create a ratio of those two areas. 90 over 160, which we can reduce to 9 over 16. And 9 and 16, as we see right away, are perfect squares, right? So 9 is 3 squared and 16 is 4 squared. Or we could also write it in parentheses, 3 over 4 squared. And that 3 over 4 squared is not a stranger, right? We have seen it before up here. This is actually our scale factor. Just one note, when we use the different lengths and segments, to make sure that we find the corresponding ones, we can go either by the similarity statement or using our diagram. Just make sure that you find the corresponding lengths and compare them when you're supposed to find the scale factor. So let's write down what we just discovered. The ratio of the areas is equal to the scale factor squared. The ratio of the areas is equal to the scale factor squared. And if you think about it, an area has 2 dimensions, and so the scale factor also has to be raised to the second power, has to be squared. So how can we use that? Let's look at our next example. Corresponding lengths in similar figures are given. Find the ratios, shaded to unshaded, of the perimeters and areas. Then find the unknown area. Perimeters are lengths, and so the ratios of the perimeters is nothing other than the scale factor. We are supposed to find the scale factor of those two trapezoids, and in the instructions it said shaded to unshaded, so we have to take the number of the shaded trapezoid, put it on top, 14 over 20, which can be reduced to 7 over 10. So the ratio of the perimeters is 7 over 10. Next, we're supposed to find the ratio of the areas. Now we discovered that the ratio of the areas of two similar polygons is the scale factor squared. So now let's take our scale factor 7 over 10 and square it. 7 over 10 squared is 7 squared over 10 squared. In other words, 49 over 100. Here is the ratio of the areas. And now this ratio we're supposed to use, or we have to use, to find the unknown area. The area of the smaller trapezoid is unknown. We need to find it. So area of the smaller trapezoid over 400 is equal to 49 over 100. Now let's go ahead and cross multiply our proportions. 100 AS is equal to 49 times 400. Now I could have already done the multiplication here, but instead, since we're now going to divide by 100, I kept it. So AS is equal to 49 times 4, and 49 times 4 is 196. So AS is 196, and our unit was inches squared. This is the area of the smaller trapezoid, and we have found all the things we needed. Very good. So now go ahead and watch the second part of this tutorial.